Let's consider a situation where we're calculating work. So we have an object of mass 5 kilograms pulled 2.2 meters across a level surface. We have an applied force that's at an angle, and we know the coefficient of friction. First thing we need to do in order to organize everything we have is to draw a free body diagram. So then here's my object. And then let's see, we have an applied force of 22 newtons. So there is our 22 Newton force. That is at an angle of 14 degrees. In addition to that, we know it's on a surface. There's a frictional force. The coefficient of friction is given. It's being supported by the surface. So we have the normal force. And then the weight, which is equal to mass times gravity, is acting on it. So we also know a few numbers. We know a distance that it is pulled, 2.2 meters. We know the mass of 5 kilograms. And we know the coefficient of friction. So mu is 0.23. So then we have our free body diagram. Now in part A, we want to calculate the work done by each force. So then we have 4 different identified forces on our free body diagram. So then we want to calculate what the work is that's done by the 22 Newton force, the work that's done by the normal force, the work that's done by the frictional force, and then the work that's done by the weight. Now, before we calculate any of these force values, let's see if anything is going to give us a 0. Remember, in order to have work done, you need a force, you need a displacement. They need to be along the same linear direction. So I'm going to note our displacement. Our object's going to move 2.2 meters in this direction. So the direction of the displacement is horizontal. So any force that is horizontal or has a component that's horizontal, we're expecting a number for. Anything that doesn't have a horizontal component will not do any work. So the normal, it is completely vertical, 0 joules. The weight, it is completely vertical, 0 joules. Always check so that you're not trying to calculate things that you're not going to get values for. The 22 newtons, though it's at an angle, it does have a component that's horizontal, and so it will do work. Friction, even though it's in the opposite direction, it's still horizontal. It will also have work done. So then work is F times D. So this would be that force times the displacement, but we need the component. So then if we do a little bit of trig to find the x component here, so that would be cosine 14 degrees, x over 22 newtons. That x component is going to give me a 21.35 newtons. That's the part of the force that's going to do work. So then 21.35 newtons times 2.2 meters. Multiplying those together, that's going to give us a work value of 46.97 joules. Coming down to the frictional force. Frictional force, that's mu times the normal multiplied by d. Now, on this, d is to the right, force of friction is to the left. They're in opposite directions. So to account for that, we're going to have a negative sign on there. Now, we know mu, we know d, we have to calculate what the normal force is. So let's do a calculation to get that normal force. We're going to set up Newton's second law, net force vertically is equal to 0 because we have an equilibrium. Well, one of the pieces that's going to come into that equation is the y component of the 22. So let's do the trig and calculate that. Sine of 14 degrees, that's going to be y over 22 newtons. And that's going to give me a y value of 5.32 newtons. So when we set up this vertical equation, we've got the 5.32, the normal, and the weight. So this will be positive F sub n, positive 5.32 newtons, negative m times g, so that's 5 times 9.8 equals 0. That gives us a normal force value equal to 43.68 newtons. Now we can plug in up here. So then this is going to be negative mu 0.23. Normal force, 43.68 newtons. And then D, 2.2 meters. That's going to give us work done by the frictional force equal to negative 22.10 joules. Part C. Calculate the net amount of work done. Well, the net amount of work just translates to the total. Okay, so then we're going to combine 46.97 joules plus 0 plus negative 22.1 joules plus 0. We added up the work done by each and every force, keeping the signs. So then the net amount of work we get for a value, 24.87 joules. So when we're calculating work, remember the essentials. It is force times displacement in the same direction. So then some forces will do work, some won't. And then free body diagram, trig, those are tools to be able to get the values that you need. Ponder physics.